Hello friends. Today I'm going to do the second video on how to build the Voice of Lancelot and how to design it. So I've gotten quite a few questions from, more specifically from Alan Hutt, Playback Mansion and I Am Mad about the design and some of the considerations and how it works with the port and standing waves, resonances of the side walls, and so we're going to look behind the scenes today and look at how to acquire the drivers and find the right ones and what I've done with the port design. Yes, basically the design parameters that went into it and the considerations. So first of all, it is the search for the right unit. Now you have to understand that Janos from Real World Audio, so he came up with the original design and many inputs went into it, but I can see also how it is sort of a domestic version of the voice of the theater, the Altec Voice of the theater, A5 or A7 type of speaker, but with more extension at the bottom and a live cabinet. So the instruments maker's take on it. So his channel is a gold mine in finding all those sort of references, even the 1956 study that he deals with, where they looked at why you can tell the difference between the best sound reproducing system that they had back then, which is probably better than most systems today, if not nearly all. And so his video on that is very insightful, and it has led to this speaker addresses the design. So I think when you start this, it is very good to just go through his videos or anything that has related to the Vol or the Voice of Lancelot to actually go into that. Now, what I'll do is I'll sort of retrace a little bit of my steps, how I went to it. And also sort of show you a little bit what you need and how the considerations. So the first thing to know is you need to get your components, as I mentioned in my first video on this. And the components are really the two key ingredients. So what he has used is the Altec 288 compression driver and the Altec 515 16B woofer, 16-inch woofer. So those are both high efficiency units, about 98, 99 dB for the woofer, and for the compression driver it's even more, like 112 decibels per watt. So what you want is to take those specs as a starting point, even if you're going to depart somewhat and you made some other sacrifices. That is really the key. And what Janos has found is that his compression driver, when there was no horn loading, actually had a very flat response from 500 to all the way up to 16 kilohertz. And for example, the driver that I found, which is this one, Electro Voice DH1A, that one, as is what I've got in front of me here, is actually flat between 1 and 16 kilohertz, because it had a little dip. It didn't exactly, it's not exactly like specs, and it had some dip between 500 and 1000, but in general the level is still very good. So I'm crossing a slightly higher, for example, and that's possible. So you can find variations. If you look at his channel, he also trying to make a more modern compression driver to the woofer. And this, for example, the one that I'm using, the Altec 414, is also a very good choice. So what you really want to start with is that. And if you do search, you can use eBay or maybe some of the forums also have for sale sections that are good sources of getting drivers. Now, what to look for? So A is that frequency response. And one of the things you need to look at the spec sheets or data that you can get, whether it's a suitable driver. So I just searched on reverb.com. I'll show you. reverb.com. I just typed in compression driver, and what I found is a couple of really nice ones. Now here is for, let's see what that costs. Here for $1,400, you got Australian dollars. You've got a Altec Lancelot 2888K. That's a bit of a later series, but that would be a very good driver. Here actually is mine for a lot less. Again, Australian dollars. That's less in US dollars. Very suitable driver. And here we've got a 255J, which is a JBL. Now let's have a look at the JBL. So here I've got the spec sheet. I found it. Well, it doesn't look as big and ponderous as this, which is an 11 kilo unit. But you know what? It might be suitable. Let's have a look at it. Very high performance rating, so it is a more modern driver. It has a 100mm pure titanium diaphragm, so that is a 4-inch edge wound, so that all sounds very good. And let's have a look at the frequency response. Now, the thing that you want to pay attention to, if you look at the spec sheets, is just don't take this for gospel too much. And this is very important, what they have measured it on, because this tells you as much about the horn as the speaker itself. So this is measured on a JBL 2380 flat horn, and then it gets this response. But now look at this. On a plain wave terminator tube, it has this. This is far more the natural response of the driver. And to what I'm sort of interested now is, and the horn gives a different support to other frequency ranges. So that balances it out, makes it more flat between the region. But we can do our own thing. Now the thing that I'm more interested in is here I can see the performance dropping off slowly under 500 Hertz. And that's a pretty good sign, because it means that we can probably cross quite low, and then it declines here. Now what you'll find with a lot of compression drivers is that it drops off with 6 decibel per octave. So for each doubling of the frequency it drops 6 dB. So that makes, if we actually apply a first order drop off that drops the frequency off, it is very easy to compensate for the 6 dB slope. And so that will just lift that response, make that response flat. This is also what I've done actually with mine. So don't be too worried about it if it has that, and usually they're made so that they don't need complex circuits to work. You know, simplicity works a lot better, especially in a professional environment. So let's have a look what it says here. It has an efficiency of 30%, so that's nice and high, 111 decibels. That sounds good. What else? It's a large format, voice call diameter, flux density 1.9 Tesla. Oh no, it is heavy. Look at that, 14 kilos. So I'm getting good feelings about this thing. I don't know how it sounds. I mean, it might not have the refinement of an alnico 288, but I think you're looking at a very suitable driver. Let's have a look at the... So here it also says 100 watt continuous program above 500 Hertz. So that means it can sustain a lot of power. So this tells me that this compression driver, if we're driving it with we wouldn't be driving this with even 1 watt. Because you just don't have that amount of power really going through the speaker. You know, if you look at where the energy sits in a signal, it's always completely in the bass region, not in the mid region. So if we're going to drive this thing with less than 1 watt, in effect, you know, even though your amp might be 25, maybe the signal is only 1 watt, it can easily handle that at 500 Hertz. And yes, so that is the tweeter side of things. So I think this thing is very suitable. I don't know how it will sound. Don't get too frightened by titanium and so on. All these things are usually have a very special material for the diaphragm, and they don't sound metallic. Not something like beryllium tweeters or so, or you know. You can hear that tinge sometimes. So if you look at the Vocal Utopia headphones, you can sort of hear the material. It gives a certain color to the sound. Here, I don't know. I don't find it present. It should be there, but it's absolutely, completely in the background. I don't feel it. It colors the sound at all. So on the woofer part, the story is a little bit different. So this is this. I won't go too far in it. And the reason, by the way, guys, that I won't go super detailed in this video is this is an advanced build. You need to use your own acumen and figure things out. So what I'm doing is sort of giving you the GPS, but you'll need to find your way. But you'll have a tool to find the things, so that you know sort of where to look. The other thing that with woofers is, here is my 414, and if I hold it to its side, you can see here how the light shines through it. And so this one has that phonolically doped, I think, cotton surround. And that is the original surround that the older Altecs came with. Now, I think personally that is those, because it's an extremely sensitive and light moving diaphragm. And you can, so it's not held back mechanically. It moves really easily, and this will loosen up if it's used enough, and gets even more flexible. So there's very little energy lost in moving the woofer. So personally, I think that is of importance here. We're looking for things that are highly efficient, that don't spend their energy on moving things around, so that you get a highly coupled. All the energy goes into moving the air, not trying to move paper or rubber surrounds around, because that doesn't give you good sound. The only thing that gives you good sound is if the movement of this translates to the movement of the air. So that coupling needs to be ideal. That is what gives you good music, because you want the air to exactly follow what the diaphragm is doing here. Only then you'll get really produce music. If all that energy, like a normal speaker that is like say something silly as 85 dB efficient, it means that only 0.3% of the energy that you put in here goes into the air moving. So the rest goes into stupid surrounds and spiders, and that's not what you want. So in your search, that is sort of the underlying thing that you're looking for, is a woofer of high efficiency. So depending on the model, this one, the 12-inch, is 96 or 99 dB efficient. And it might be a bit higher when you actually put it into a case. Now, then there's the other element which comes next. Why the low crossover is sort of interesting to you maybe, is because if you look at, especially if you have these out of a wall and not in a corner, is you have the baffle step effect. So what that means is, if the response of your speaker will go something like this, depending on the width of your baffle, because if you look at your case, the sound will go 360 in the low regions, but it will only go that way. It gets blocked by the case. It will only radiate in half of the circle once the frequencies get higher. So this is why the total sound pressure that you experience in front of the case, it will actually do something like this. It will be far more ragged, but it will run like that. Now, one of the things that happens with a low crossover reach, and this usually happens sort of, say between 200 and 700 hertz, that this happens. It depends on the width of your baffle, but what you now can do, if you imagine this woofer, and we have a compression driver that at the high end can actually cross low, we can actually run off the woofer like so. Just to step one back. So what you need the sound output needs to do sort of this. Now, how we can do this is have the woofer do this, and then we let the tweeter come up like that. So this way we don't need a baffle step field correction network to actually get this step in. We're just using the crossover point between the woofer and the compression driver. So that's the other trick that is happening here in the Voice of Lancelot design. So if we get the right drivers, then we have a lot of this sorted. Now then there was questions, and Alan also asked questions about how the room supports this, and we'll get into that into the next video. I think this is the part about the driver selection, and let me see if there was anything else, questions on that, just to make sure that this section is complete. No, I think we'll just keep it at this. We're at 15 minutes, so this will be probably maybe a 3-part short series on the design of the Voice of Lancelot. So I think this was the bit about the driver selection, just the high level overview, and the point of crossing it low. It also has another influence. You can actually have a look at the Schroeder frequency if you have a look at that. So there is a bit of conjunction in your room that if you, depending on the size of your room, in the lower frequencies, and then f times 4. So if you look at if this is your frequency spectrum, and sorry I didn't explain it there, but yes, here at the low end, the F of the Schroeder frequency is where you get your room mode, so you get reinforcements of the sound depending on the size of your room. And you can actually calculate that. Let's just go over that quickly. There's a good calculator online. Here it is. I'll put a link in the description. And you can actually put in the size of your room, and it will tell you all the axial the actual room modes in your room, where they occur, depending from your sizes. And then it also gives you a table where the length and the width of your room actually co-join, where those frequencies actually join, and that's where you usually get peaks in your response. So that's a useful tool to helping you predict. That was one of Alan's questions, how the room will support it. But this will it will not actually tell you, but it will tell you the problems where you might see peaks. But that is also called support in the lower regions. So going back to the Schroeder frequency, then you have it at the high end, you get your whole room where sort of the sound bounces around. And it's not so much standing waves, you don't get peaks here anymore, so it's smooth. But this is sort of how you build up a sound pressure in the treble region. And this transitions from that frequency and then at 4 times. So here you get a little bit, it transitions from those room modes to being more stable, and there you don't get any peaks anymore that you get down here. And the thing is that luckily with a low crossover point you'll be operating a little bit between these levels, and what that allows is, even though you only have 2 drivers, you'll see that you can balance the sound in your room for these 2 things. The levels sort of co-join with this if you're lucky. Now if your room is very small, that will be a bit out of balance, but the 500 Hertz crossing, and even if you do it a bit higher like I had to do, is I went up to 800 Hertz just because my driver wasn't actually perfect per spec. You will be able to make use of this. And so it's a nice tool of balancing out your room. That's one of the advantages of this design and crossing low, apart from the fact that crossing low just means your hearing, which is most sensitive to between sort of 1 and probably 3 kilohertz, much higher up. So you're crossing in a region where that frequency and the wavelength is still large, and your ear is not as sensitive to it. So that's the crossing over point and the drivers. In the next video I'll go into into which is this topic, which is also how the musical notes work in a cabinet, the frequencies and the quarter wavelength, and where you can see resonances here, and what Janos had a whole video of how you make your cabinet sound natural, and so that you pick dimensions that are on the musical scale, and that way you don't have alien tones in your cabinet. So I'll go into that into that part of the cabinet design. All right, that's it for now. This video has been long enough. I wish you a brilliant day and hope to see you in part 2 of this series. Bye bye.